This video series is to accompany the Cisco Netacad Switching, Routing, and Wireless Essentials course. This particular video covers Module 15, IP Static Routing. In this video, we'll cover these objectives: static routes, describe the command syntax for static routes, configure IP static routes for v4 and v6, IP default static routes for both v4 and v6, floating static routes, and configuring static host routes. 15.1 Static Routes. Static routes are commonly implemented on a network, and this is true even when there is a dynamic routing protocol configured. So static routes can be configured for v4 and v6, and both protocols support the following type of static routes: standard, default, floating, and summary. And static routes are configured using the IP route and the IPv6 route global config commands. So when configuring a static route, the next hop can be identified by an IP address, exit interface, or both. However, or how the destination is specified creates one of the three following types of static route: next hop route, and that means only the next hop IP address is specified; directly connected static route, and that means that only the router exit interface is specified; and then fully specified static route, and that means the next hop IP address and exit interface are specified. The v4 static routes are configured using the following global config command. You have your location. We do IP route, the network address, the subnet mask, and then the exit interface, the IP address, and the distance. So either the IP address, exit interface, or the IP address and exit interface parameters must be configured. And on v6, they're configured using the following global configuration command: IPv6 route with these parameters. Most of the parameters are identical to the v4 version of the command. The figure below shows a dual stack network topology. Currently, no static routes are configured for either v4 or v6 on this topology. Each router has entries only for directly connected networks and associated local addresses. So R1 can ping R2, but it cannot ping R3. And I'm gonna zoom back up just for a second. So R1 can ping R2, but not R3. So each router has entries only for directly connected networks and associated local addresses. So R1 can ping R2, but it can't ping the R3 LAN. 15.2 Configure IP static routes. In a next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop v4 static routes are configured on R1 using the IP address of the next hop, R2. So we have the config commands here, and here, and here. And the resulting routing table entries on R1 looks like this right here. The commands to configure R1 with the v6 static routes on the 3 remote networks are as follows. We do IPv6 unicast routing. We set the route. We set the next route. And then we set the third route. And then we see on the right-hand side the results of the new routing table. When configuring a static route, another option is to use the exit interface to specify the next hop address. 3 directly connected IPv4 static routes are configured on R1 using the exit interface. We use these 3 examples right here with the result below. And with this example, we do 3 directly connected v6 static routes, and they're connected on R1 with these commands here, and then we have the results on the right-hand side. So in a fully specified static route, both the exit interface and the next hop IP address are specified. And this form of static route is used when the exit interface is a multi-access interface, and it is necessary to explicitly identify the next hop. So the next hop must be directly connected to the specified exit interface. So using an exit interface is optional. However, it's not necessary, or however it is necessary to use a next hop address. So it's recommended that when the exit interface is an Ethernet network, that the static route includes a next hop address. And you can also use a fully specified static route that includes both the exit interface and the next hop address. And we can see the results on the right side here. For the v6 address, there's a situation in v6 when a fully specified static route must be used. If the IPv6 static route uses a v6 link local address as the next hop address, you want to use a fully specified static route. And the figure below shows an example of a fully specified v6 static route using an IPv6 link local address as the next hop address. And we see the example of that right here with the results. The reason a fully specified static route must be used is because IPv6 link local addresses are not contained in the IPv6 routing table, and link local addresses are only unique on a given link or a network. The next hop link local address may be a valid address on multiple networks connected to the router. Therefore, it is necessary that the exit interface be included. And the following example shows the v6 routing table entry for this route. Notice that both the next hop link local address, or next hop link local address, if I can say that right, and the exit interface are included on this result. And last, we can do the verifying a static route. We do the show IP route or show IPv6 route. We can also use ping, and then we can also use the trace route command to verify routes for the static routing. 15.3, configure IP default static routes. A default route is a static route that matches all packets. A single default route represents any network that is not in the routing table. And routers commonly use default routes that are either configured locally or learned from another router, and the default route is used as the gateway of last resort. And default static routes are commonly used when connecting an edge router to a service provider network or a stub router, and that's a router with only one upstream neighbor. And the figure on the right shows a typical default static route scenario. The IPv4 default static route, the command syntax for the v4 static route is similar to any other IPv4 static route, except that the network address is 0.0.0.0 and the subnet mask is all zeros. So the all zeros in the route will match any network address. And a note here is that the IPv4 default static route is commonly referred to as the quad zero route. And the basic command syntax for the IPv4 default route is IP route. You set all the zeros. And then v6, the command syntax is right here, IPv6 route, and you set : /0. The example here shows the IPv4 static route configured on R1 with the configuration shown in the example. And then the IPv6 route is shown right here with the example. So we do IPv6 route : /0 with the IPv6 address. The show IP route static command output from R1 down here shows the contents of the static routes in the routing table. Note the asterisk next to the route with the code of S. The asterisk indicates that this static route is a candidate default route. And sorry, I drew over that here. Give me just a second. Let me erase all of that. There we go. And you see your example down here. I ended up drawing over that. So you want to notice that the static default route configuration uses the /0 mask for the IPv4. And then remember that v4 subnet mask in a routing table determines how many bits must match between the destination IP address and the route in the routing table. So a /0 mask indicates that none of the bits are required to match as long as a more specific match does not exist. And then finally, for the show IPv6 route static command, we see our example down here, and much like the IPv4, it matches because of the : /0. 15.4, configure floating static routes. Another type of static route is a floating static route. Floating routes are static routes that are used to provide a backup path to a primary static or dynamic route. And the floating static route is only used when the primary route is not available. So to accomplish this, the floating static route is configured with the higher administrative distance than the primary route, and the administrative distance represents the trustworthiness of a route. And if multiple paths to the destination exist, the router will choose the path with the lowest administrative distance. And by default, static routes have an administrative distance of 1, making them preferable to routes learned from the dynamic routing protocols. And the administrative distance of a static route can be increased to make the route less desirable than that of another static route or a route learned through dynamic routing protocol. So in this way, the static route floats and is not used when the route with the better administrative distance is active. The commands to configure default and floating IP default routes are below. So we have IPv4 and IPv6, and the show IPv route, or show IP route, and the show IPv6 route verifies the default routes to R2 are installed in the routing table. And we want to note that the IPv4 floating static route to R3 is not present in the routing table. And then last, we can test. So what happens if R2 fails? To simulate this, R2 shuts down both of its serial interfaces. R1 automatically generates syslog messages for the link going down, and a look at the R1's routing table would show the secondary route being used. 15.5. Configure static host routes. A host route is an IPv4 address with a 32-bit mask, or an IPv6 address with a 128-bit mask, and the following shows the 3 ways that a host route can be added to a routing table. You can automatically installed, or it can be automatically installed when an IP address is configured on the router, configured as a static host route, or host route is automatically obtained through other methods discussed in later courses. On automatically installed host routes, the Cisco IOS automatically installs a host route, also known as a local host route. When an interface address is configured on the router, a host route allows for a more efficient process for packets that are directed to the router itself rather than for the packet forwarding. And this is in addition to the connected route designated with a C in the routing table, and the local routes are marked with L in the output of the routing table. A host route can be manually configured with a static route to direct traffic to a specific destination device, such as a server shown in the figure here. The static route uses a destination IP address of 255.255.255/32, and that's the mask for the v4 host routes, and a /128 prefix length for the v6 host routes. And these examples here show the v6 and the IPv4 and the IPv6 static host route configuration on the branch router. And then we can use the show IP route to see the information here, or the show IPv6 route to see the v6 route information. For v6 static routes, the next hop address can be the link local address of the adjacent router. However, you need to specify an interface type and an interface number when using a link local address. And in the example here below, the original IPv6 static host route is removed, then a fully specified route configured with the v6 address on the server and the IPv6 link local address of the ISP router. So hopefully you learned a little bit in this video, and this is screen 1. You can pause your video here to read over these. This is screen 2. You can pause your video here if you want to. And finally we have screen 3, and hopefully these videos were helpful for you.